Carbon emissions have been increasing exponentially since the early 20th century, leading to a slow increase in temperature. The damage of this excess heat can be seen in much of our landscape, such as retreating glaciers, an increase in ocean acidity, and a severe loss of biodiversity. If we continue on this path, we are bound for mass extinctions of organisms and, eventually, ourselves.
In the ocean, these changes can be seen in the form of rising sea levels, from glaciers and most importantly to our mission, ocean acidification. As carbon dioxide, one of the most catastrophic of the greenhouse gases, continues to be released through various emissions, the ocean oftentimes is responsible for dissolving that CO2 and transforming it into calcium carbonate. However, too much CO2 in seawater results in the pH becoming more acidic, harming marine life on a multitude of scales. At the base of our global marine ecosystems is the often overlooked and misunderstood species of algae, coccolithophores. To combat rising carbon dioxide levels, coccolithophores as a whole, particularly our species Emiliana huxleyi, are responsible for 20% of global carbon fixation and 50% of calcium carbonate that sinks becoming part of marine sediments. In calcium carbonate form, carbon dioxide molecules that were once rampant on the atmosphere are now fixated in a form where they could remain trapped for millions of years, undisturbed.
Coccolithophore integrated technology for yielding carbon offset and fixation, also known as CITYFIX, is an urban algae tower that utilizes these phenomena to calcify carbon dioxide in CO2-rich environments. The tower contains an array of sensors, a reverse osmosis system, air filters, and a reservoir to ensure it can photosynthesize autonomously for long periods of time, releasing oxygen into the atmosphere and isolating calcium carbonate, which can be used in medicine, construction, agriculture, and more.
This is our third iteration of our original CAD model for carbon capture using algae. To start with, we have this very large tube right here in the middle, which holds the algae in median while in use. This is a see-through tube which allows sunlight to get in. On top, we have these two sensors right here. This bigger one right here is a dissolved CO2 sensor, which measures the CO2 in the water, which allows us to measure the efficiency of the algae. This smaller one over here is an oxygen sensor, which goes into water as well and measures if the algae is getting enough oxygen to produce at its best capacity. Next to those, we have two air filtration units. These are the small filters which allow air to get in, but no small particulates and no debris to get in. There is a pump down here. This pump slowly filters out the algae, filters out the calcium carbonate created by the algae, and also filters the median, allowing for a long median use. There's two access points into the for this pump, one located here and one out here. This one is the intake valve, and this goes into a reverse osmosis system, which allows for filtration and reuse of median multiple times. At the bottom, we have this large tank. This tank stores extra median, so once in a while, Bree will flush the tank out of median and add more in, keeping the algae healthy with brand new median. This system of filtration lasts around close to a year before it needs replacing and refilling, which is a lot longer than it normally take in just a closed tube. To run these pumps and sensors, we have a solar panel and a battery here, which are connected to control electronics. This front board right here runs the sensors and takes data and sends it to the pump, which calculates the efficiency the pump needs to run at. And behind that, there's another board. Let's see if I can go to it. There's this stacked board here, which runs the pump and does some calculations and stores data about the efficiency of the entire unit and when it needs to be replaced. Thank you for looking to our model.
To conclude, CITYFIX, brought to you by UPrep Algae Biosolutions, Our Geniuses, is a first-of-its-kind algae photobioreactor that releases oxygen into the atmosphere, calcifies carbon dioxide, and opens up a path where humanity transforms its emotions into the building blocks of the future.